What developers get wrong about software architecture. Martin Fowler. What is he saying? Hello, I'm Chris Athenis. I'm a KMP developer. A tech support. They said they're coming out for that for sure tomorrow or Monday, Tuesday. All right, we'll see. I'm not holding my breath. I'm going to be reacting to this Martin Fowler. He's a well-known software architecture guy. Um, People like on the mostly back end. This is all these the guys are all back end guys. It's like I haven't found too many front end people because it changes so damn often, and all the architectures are all different and strange and obtuse, but all doing exactly the same thing. So yeah, they haven't really covered that too much. But all right, so let's see what he has to say.
I mean, the reason we use the word architecture is we're drawing a metaphor from the construction industry. And as in typical with software development, we got the metaphor completely wrong. Because in the
as we are known to do,
software, if in the building industry, what an architect does is concentrates on the experience of people working and using in the building. I mean, if we were to say what is the equivalent of an architect in software development, it would be user experience designers.
Yeah, UI. Not the back end microservices, break it up. Look, as far as your customer is concerned, your app is the UI. How they see it and how they interact with it is going to go through a UI unless they're command line crazy. And that's not, I mean, I'm not talking about those people. I'm talking about people that go through a UI. And architects, I'm like, I always talk to the architects. So have you considered how this is going to impact user experience? Like, no, this is the back end architecture. The front end is your problem, Chris. Like, what? Wait a second. Well, what are we trying to do? And how are we trying to do it? That will dictate how the back end. The back end can be generic. Like, you wouldn't do what? Okay, keep going.
It wouldn't be anybody concerned with the internal design of a system. I'm very conscious of this because I'm married to someone who does do that work. She's a structural engineer. And that's completely different to architects.
Okay.
And I can tell you, traditionally, structural engineers and architects get on.
Like, talking about building bridges now? Does he mean structural, like, as in, like, civil engineering, where you have to building spans of bridges and make sure that the materials are met for demand? You're only doing one thing. You're only just doing a bridge from here to there. You're not doing anything else. You're not going to change it. You're not going to modify it. It needs to stand for 100 years, maybe 150 with tolerances depending on the traffic load. And that's different than creating something, a problem, a solution for a moving marketplace, for users have a changing set of demands that have other competitors who are trying to meet their demands better, to how you can make something that can change over time and be modifiable over time and actually be supportable by having it being onboardable and all that stuff. That's a little different than civil engineering, building bridges design. Okay, let's keep going.
Just about as well as the average programmer and enterprise architect does in our industry. So I think a better metaphor for what architecture should be like in the software world, there's a nice little talk you can hunt around on YouTube by another colleague of ours, Eric Durnenberg, and the talk is called Architecture Without Architects. And
I don't know what that means. Now you're confounding so many things. Let's keep going.
His point of view is that if you're going to look for a metaphor, a better metaphor for architecture is city planning. Because with city planning, you've got something that's much more dynamic and vibrant. Things are changing.
Why do we have to have a metaphor? How about we have computers that can compute things? We have things that can be stored, things be gained. There's certain things that are computable. And then there's customers who have problems that may be, we want to find, have some sort of computability problem, or a storing stuff problem, or creating an interface into some problem that can be solved on the computer, be monitored by the computer, be looked at by the computer, and that we as developers have the ability to apply our software knowledge to that solution. Why do we have to have a metaphor for that? Why is there going to be why do we have to try and elevate that to more than it already is? It's pretty amazing that we can apply engineering skill sets to solve problems. Why do we have to have another metaphor? Mr. Fowler, let's keep going.
Changing all the time in city planning, and you have to react to that while at the same time trying to keep some kind of coherence.
Now, a lot of people want to plan a city and that's it. They want to mow down downtown. They want to put the highway through and that's it. That's all problem solved after that. They're not talking about this changing, modifying thing. I mean, that's really what's going on. But when these things are laid down, oftentimes like, well, this is it. We're gonna let grade. We're gonna have the car thing is gonna be a big deal. So we want to get rid of the downtown and put a highway through it. Just bulldoze it, get everybody out of there.
Coherence across the whole picture. It's important to have some kind of planning activity because otherwise you end up with an overly chaotic city. But at the same time, you
As
can't
they all are.
come up with a design and let it set because things are always going to change around you. And I think
That's a bad metaphor. I don't like that metaphor. Why do you have to use a metaphor? It's just engineering. People have problems. We have a computer that can compute and save and store data pretty efficiently. We do have a problem that can be solved with that. And do we have Can we address those customers' demands in a profitable way? So it can be like a 1 or 3 person, or 5 person operation, 20 person operation, or you have some other set of customer that's not the direct customer, some future customer where you get investors that's now becomes your customer, meeting their demands about what they think where this thing is going to be headed in the future, so they can snack up that customer base. This is what's going on, not architecture, blah blah blah. It's how do we write software in a way that we can change it easily. But first of all, attack a problem so we can achieve it. We can achieve some sort of product market fit where we have the market of people and their problem, and we can address those things. That's first one. And then the second one is how can we scale that if we need to scale it, or not just scale it, but also make it modifiable, understandable, readable, debuggable, monitorable. All these other constraints happen after you have product market fit, right? It's like, I need product market fit first because there's lots of software out here that has no users. There's more servers than users, and that is not fun because what the fuck? Like, the people that should be left over after this shakeout are people that want to solve problems, not solve this using this technology. They want to solve in general people's problems, and we'll adapt to whatever technology we need to use, whatever libraries, whatever operating systems, whatever, how we want to deploy this thing. But we have to find a customer that has a problem that we feel that we can solve, and we can take a stab at it. Either do it better, faster, more cheaper, more fun, different context, different country, different culture, all the things that make it so we can add the value, and that we can do that profitably. It's not this, we're building a city. It's like, no, we're lucky if we get to build a shop that people want to come into. Man, I need to get my beard trimmed.